Hi all. Today we discuss section 22.9b. This is Gauss's forward interpolation formula. So this is the formula yp equal to y naught plus p times delta y minus 1 plus etc. So in order to remember this formula, we need to remember this diagram. From y naught, we use in the first term we will use y naught, and in the second term we will have this delta y minus 1 times this p. Then the next term we will have this term delta square y minus 1 along with this one, what we have exactly done in Gauss forward interpolation formula. So the only difference is the movement of this or the selection of these values from the table. And the next time we will have this delta cube y minus 2, and we have delta raised to 4y minus 2, and we will write the next term also. So that contains how will you write the next term? That's the idea here. So in order to write the next term, we will use this delta raised to 5 y minus 3. This is delta raised to 5 y minus 3 along with this factor, something divided by 5 factorial, that is p minus p plus 2. From this, starting from this, we have p here, then we had p plus 1 here, then p minus 1 here, then p plus 2 here, then you incorporate p minus 2. So p plus 2, p plus 1, p minus 1, then we have p minus 2. Okay, so we have 5 terms divided by 5 factorial times this plus etc. So in order to write the next term, we will use this factor delta raised to 6 of y minus 3. So in fact, this is the values from the backward difference table, forward difference table. So this is in fact this y minus 1 here. Okay, so we have the same thing here. We have delta, if this is y minus 1, then the next column we will have delta y minus 1 here. Okay, so in the next here we have delta y minus 2 in the table, and here we have delta square y minus 2. So we are neglecting these terms from the table, so we choose only this much values to evaluate this. Okay, so using this we will discuss an example illustrating this. This is the example. Interpolate by means of Gauss backward formula. The sales of a concern for the year 1976. Given that these are the values, in 1940 we have 17. These are the rupees in lakhs, 17 lakhs, 20 lakhs, 27 lakhs, etc. So using these values, we need to interpolate the sales for the year 1976. Okay, so first of all, you consider the interval of differencing, that is 10 here, 1940, 50, 60, 70, 80. So they are all at equal intervals, that is the length of the interval is 10, and using this fact we define p is equal to x minus 1970 divided by 10. X minus x naught, this is first we fix x naught. This x naught is equal to 1970. This is because of this fact we need to interpolate the value value at 1976, that comes somewhere here. So we set x naught as the x value just before the 1976, so that is 1970. So using this fact we define p is equal to x minus 1970 divided by 10. Okay, so in fact this we set this is our p, then we construct the table. This is the table. These are the x values. Now we evaluate p value for each of these x's. So that is 1940 minus 1970 divided by 10 and so on. So if you take this 1970, you have 0 here, and here we have -1 and -2, -3 here, and here we have 1, and this is 2, and the corresponding y values, that is 17, 20, 27, 32, 36 and 38. So these are the y values. Now you evaluate delta yp. So these are again the forward difference. We know that if you discuss the formula, it contains the forward differences, delta. So we use the same table. Even though this is backward interpolation formula, we use the same forward table, but we take the differences in backward position. That's the name that justifies the name backward. So here we have 3, that is 20 minus 17. Here we have 7. This is our we write it as 3 here, and this is our 7, and this is our 5. 32 minus 27, and 36 minus 32 is 4, and 38 minus 36 is 2. So this is our delta y minus 3. This is our delta y minus 2. This is our delta y minus 1. This is our delta y naught, and this is our delta y1. So these are the values. Now you have the difference of these two, then we will get the second order. So this is 4 and 5 minus 7, that is -2. This is 4 minus 5, that is -1, again -2. So these are the values. Delta square of y minus 3. This is delta square of y minus 2. This is delta square of y minus 1, and this is delta square of y naught. So these are the values. Okay, now you have third order. So here we have 4 minus -2, that is 6 here, and we have 6 here, and the difference between these two, -1 minus of -2. So we have 1 here, and -2 minus of -1, so that is -1. So we have this is our delta cube y minus 3, and this is delta cube y minus 2. This is delta cube y minus 1. Okay, now take the difference, fourth order difference, that this will be 1 minus 6, that is sorry, this is our -6, that is -2 minus 4, that is -6, 1 minus 1. Now take the difference, 1 minus of -6, so that will be 7, and -1 minus 1, that is -2, and this will be delta raised to 4 y minus 3. This is delta raised to 4 y minus 2. Okay, now take the difference of these two, that is -2 minus 7, that is -9. This is delta raised to 5 y minus 3. So these are the values. Now we use before we go into use the formula, we denote those values that we really wanted to get the formula. So we need in this formula, in fact I will write the formula again here. This is our formula. So first we need y naught. So this is our y naught. Y naught is 32, sorry, x naught is 1970, then this y naught is 32. So this is our y naught. So first we want this number 32. So this is our first number required for the formula, and p times delta y minus 1. We move backward, so that's why this is called backward interpolation. And we want to we have selected y naught and this delta y minus 1. Now we choose delta square y minus 1, so that come this way, delta square y minus 1. So first we move on to this and then come to this point and again come to this backward. So we have this number here, delta square y minus 1 here, and then next time will be delta q y minus 2, and then we, after going to this, we come to this number, and that is written here, delta raised to 4y minus 2, and finally we have this delta raised to 5y minus 3. So these are the values. So this is the way we choose the values to evaluate this formula. So now using these values we evaluate this expression. Okay, so we already in order to evaluate the y value at x equal to 1976, we set x equal to 1976. So using this x we evaluate p. In order to evaluate this formula, where p will be 1976, that is x minus 1970 divided by 10. So this is our p. So p is nothing but 0.6 and x equal to this one. Okay, now you apply the formula. Yp will be, this is our y value at x equal to 1976, that is equal to y naught. Y naught is this one, 32. So 32 plus, we have p times this, that means p times this one. So p is 0.6, that times this number 5, plus the third term will be p plus 1, that is 0.6 plus 1 times p, that is 0.6 divided by factorial 2 times this times delta square y minus 1, that is this number, delta square y minus 1, that is minus 1. Okay, now we have p plus 1 into p minus 1, 0.6 minus 1 divided by factorial 3 times this delta q y minus 2, that is delta q y minus 2 is this one, that is 1 again, so you multiply it with 1. Now the fifth terms, okay, the second last term will be p plus 2, that is 0.6 plus 2 into 0.6 plus 1 into 0.6 into 0.6 minus 1 divided by for factorial, so this is in fact for factorial, times this value, delta raised to 4 y minus 2, that is minus 2, so this times minus 2. Okay, plus the last term, that is 0.6 plus 2, 0.6 plus 1, 0.6 minus 1, sorry, 0.6, then 0.6 minus 1, 0.6 minus 1, 0.6 minus 2 divided by 5 factorial times delta raised to 5 y minus 3, so that is this number, that is minus 9. Okay, so when you evaluate this expression using a calculator, you will get I really don't want to evaluate all this in this video. So you evaluate these numbers, then you will get 30.114368. So this is the y value at x equal to 1976. So we write the sales in the year of the sales in the year 1976 is 30.114368 lakhs. Suppose all the sales are given in lakhs, so this is the answer for the exam. Okay, so this is the illustration of Gauss backward interpolation formula. In the next video we will discuss Stirling formula. These are all central difference interpolations.